will develop on the dependency injection topic. I should thank Alex for a great introduction, which was completely unintended. So I should blame whoever did the schedule. So I should blame myself. By the way, let's start. What is dependency injection? Dependency injection is a means to achieve the last, but not least, of the great solid principles, which is dependency inversion. This principle was first formalized by Robert Martin in the mid-90s, I think, and it says two things. High-level components should not depend on low-level components, but should depend on abstractions. And abstractions should not depend on details, but details should depend on abstractions. So, the idea of inversion can be achieved by many means, one of which is dependency injections. Other means are, for example, the service locator pattern, or plugin, or mixins, some other like those. But I will focus just on dependency injection, which is not this. Can anybody spot what's that? Raise your hand. What's that?
Java Spring Framework.
Yeah, that's Spring Framework. This is the XML version for the configuration employed by Spring Framework. Now I've got some slides which can show you how large this is. Okay, this is about 1,000 lines. Okay. Spring Framework is a Java library which performs inversion of control. You don't need to do this to achieve dependency injection. And by the way, this is a bad usage of the Spring Framework library. This is an application which was packaged by layer instead of by feature, meaning that everything depends on everything, so there is no clear dependency graph. And this results in a huge XML file which you can't read, and everything is a mess. And many people think that this is dependency injection. This is not. This is one way, for example, to not use XML even when using Java and Spring. So if somebody says, this is dependency injection, I don't like it, forget about this. You don't need it. Dependency injection just wants you to depend on abstractions and not on concrete implementations whenever you are doing your design. There are things you should identify because of their roles, and other things that you should use just as implementation detail. In the terms of Misko Agre's blog, I don't know if anybody reads the Google testing blog. There are some things which should be injectable and other things which should be viewable. When using dependency injection, you try to achieve a highly cohesive class, so a class that does well just one thing, solid, the single responsibility principle. Whenever you need to address a different concept, you invoke a peer, something that has got a different role in your application. There is no easy way to identify roles from the beginning. They usually emerge, they usually grow when you develop your application, when you go on with testing, when you go on with design. So don't try to identify roles at the beginning. But try to inject whatever you can. This is an example of an hard-coded dependency. So you are trying to achieve high cohesion by using the single responsibility principle. So you're not mixing constant in a single class, but you are forcing the usage of a certain implementation of your repository. And you're forcing the use of a certain DB driver in your applicative code. What's the problem with this? if you use this kind of instantiation, you will code to an implementation. If you start by this, you will try to use whatever this implementation of user repository is, and you will use every kind of method you can extract from this specific implementation. Consider this version. This is very easy, nothing strong, nothing strange. Consider starting by this. This is a clean slate. The user repository may not exist. This is called wishful programming. How many of you have already heard about wishful programming? Okay, so you just start coding your user service. You don't have a user repository class yet. And you just write some code thinking about what the interface of the user repository should look like in the best possible world. Then, if actual repository or concrete classes that you built don't respect its interface, you just code an adapter or whatever you like to make your class fit what you need. This way, you don't depend on the implementation because maybe the user repository is from a third-party library, you don't have control over it. This doesn't mean that you should use that implementation as is. Well, I could just, I'm taking the answers at the end of the talk because maybe your doubts are already solved in the next slides. Okay? Thank you. So I could end the talk here, but there are some myths floating around dependency injection, especially in the Python world. The first thing I have heard, and this sometimes comes out in blogs, on Twitter, on mailing lists, whenever you talk, is Python does not need dependency injection. So you must use dependency injection in Java or in other statically typed or lexically poor languages. Why? This is often a myth. In Java, you can do some things like automatic wiring of dependencies based on type information. So this is a way of achieving dependency injection in an automatic fashion. But it doesn't mean that you don't need it in Python. One thing that I suspect is that since Java is really a slow language to use, you need to take a lot of effort in writing Java code because it's, you don't like it if you're here probably. Since it takes a lot of time, you want to achieve the maximum possible reuse from Java code. So you use a lot of dependency injection, so you can take one class that took you 2 weeks to write and use it every time you need it. In Python, you would probably take 2 hours to code the same class. So many times you don't mind, but that's not a good way to go on. In my personal experience, I had to fork a lot of Python code, a lot of third-party libraries, because they did not provide hooks, they did not provide dependency injection, any way to inject peers, even though there were clear injection points. That's because dependency injection is not really used. Whenever you need to fork a library just to perform dependency injection, that's a big boo for you. Okay? Especially if you're writing a library or a framework. If it's your application and you're just your application and your clients are just expected to use your application, you can forget a bit about it, but I don't recommend this. So another myth is it makes your interface dirty and breaks encapsulation. This is a very precise thing that it was told once. I think this is a myth as well. And it largely created by the string way Java of achieving dependency injection. This is called setter injection Java. This is just a way that Spring uses to inject peers into a class. You don't need to use it. There are reasons because Spring uses it. It has something to do with wiring, with the way that dependencies are coded and are injected in your application, but you don't need to do it. If you achieve construction injection, just in the slide we saw before, this is perfect. So don't mingle the two concepts. What is an interface? I think that everybody has heard about the concept. This is the English term for interface. It's a device or a system that unrelated entities use to interact. I think it's a good definition. It's actually from the Oxford Dictionary. In Python, we don't have a concept of formal interfaces. We've got pipe protocols, loop interface, and now ABCs. They are fine, but the point is, the fact that you don't have a formal concept of interface does not mean that you should not program to interface rather than to implementations. You should always think in terms of interfaces. Consider this basic example. This is a car cockpit. You can drive almost any car if you've got any driving license. You don't need to know the specific make or model of such car. So we could imagine an interface like drivable, something like that. You don't have to use ABC. You don't have to use anything. When you do duck typing, what's important is to think about your interface and just use methods for your interface. I mean, I might have a great car doing a lot of things. So this is my car. You can make me a breakfast whenever I like, if I press the right button. But it does not mean that I cannot drive it. I think, okay, you might have mentioned wrong. Doesn't matter. So whenever you need a car, your object, and you are duck typing, just think in terms of the interface you're using, and don't go too deep in the implementation detail. Somebody else who's got a different concept of what this car does will be able to use this method, but you shouldn't. And what about this? This is a great thing that has come to my attention. How many of you think that objects of this class have got different interfaces? Nobody? That's fine, because many people usually complain about this. You know, can you remember that the constructor is not part of the public interface of your object? It's just something that happens in Python, that the initializer is inherited from parent classes, but many languages don't offer this feature. So in Java, as an example, you never inherit constructors because you never inherit something that is not part of the public interface of your object. So if anybody says that dependency injection breaks interfaces because you might have something like that, it just makes no sense. And what about encapsulation? I think there is a lot of overlap between some concepts like abstraction, encapsulation, and things like that. I had to find out a way of delivering such a concept. So the way that ISO says encapsulation is the property that the information contained in an object is accessible only through interactions at interfaces supported by the object. So consider this only. Can we achieve this kind of encapsulation in programming languages like Python or Java, in your opinion? I think it's almost impossible because you always have a way to introspect what's inside an object. You have a way to access private variables. You can access the bytecode. You can access everything. There is no way we can achieve a perfect encapsulation in this sense. I think about network stacks, that's almost a better encapsulation. So I have a proposal which arose during a conversation with a former colleague of mine. I don't remember where he took this information, so I might not be giving the right credit to the proper people. So encapsulation is the property of a system to work by relying on its interfaces only. This is slightly different. So the point of encapsulation is not that you don't have, no, that you mustn't use the methods of an object if you're not part of the interface. The point is that you don't need to use them. I will clarify in a moment. This is a washing machine. I think it's quite encapsulated. It's got a control panel. And you just start, stop it. You just have a program. And it does whatever you like it to do. This is the same machine, but it's open. So you can see inside it. You can see through it. You can see its details. Does it matter? Does it mean that you can't use the control panel anymore? No. You can just use the control panel and you can go deep inside. Okay, it's not clear, it's a bit, maybe it's a bit broken, but...
You may use the control panel, but it won't do anything.
It's just open, don't worry. The fact that you see inside an object is not a problem for encapsulation. So many detractors just say that dependency injection kills encapsulation because it exposes your dependencies, your peers, to the outside world. They just prefer to keep the dependency inside and instantiate them inside the class. Because this should make the object more encapsulated. You don't have dependencies, you have nothing. From the outside, you see nothing. This is a bad idea because you get a really large and complex and hardwired object. And you don't want to hardwire anything. Why I'm speaking of wiring? Has anybody already heard of wiring? I suppose that everybody using the JavaScript framework knows what wiring means. Wiring is just something taken from the electronics. What happens in electronics? You just have small components. You do, well, one thing, one small thing, and then they are connected together into a higher level picture. So there are a lot of small components that you can use and reuse and reuse. And you can trust them to work as expected. You can say that there are ICs or microprocessor or everything which is smaller and it's less flexible, but they are more powerful. Okay, you cannot have a microprocessor like the modern ones we are using by just wiring something like that. That's a hardware problem. I think that every engineer would use manual wiring if he could, if it wasn't possible to do it in the real world. So the whole idea around wiring is build small classes. And there are two solid principles and wire them together. So inject dependencies as needed. This is an example of how you can simplify your life using Dependency. This is an experimental library I wrote. You don't need to use it. So remember, if you don't need an IUC or any library to perform your task, that's always better. But as soon as you feel the need for it, you can try. This is a kind of pre-baked configuration for your code. So you provide the small level components, and then if you just have one use case, if you feel that most people will just use a simple configuration, a default configuration for your code, you can provide a kind of pre-baked configuration. People doesn't need to do anything. People that doesn't want to go in an extreme detail in what your application does already have an entry point to use it. In this case, you are saying that the user service is what your user wants to know about. This has got a set of pre-baked dependencies that will be injected at runtime. Now, this looks quite like Java Spring, if you have used it. Here we take an app context, which is just an object which is able to read configurations and to provide instances. In this case, we are using a singleton. So, could you spot this? Spot singleton means that you are taken away with the burden of using the singleton pattern if the application context which makes an object singleton for you. So since you are not asking, you're not instantiating anything in your code, you are just specifying how long or how it should be instanced. And it's a container that will let you use the singleton scope. Here you can see I have called provide twice. The object is the very same, so it's kind of cached in the application context. And here you have a pre-wired object instance of user service. The third myth about dependency injection is that you don't need it because you can just monkey patch. I think that Alex already told you about this. And there are some serious issues with monkey patching. Let's consider an example that I talk about. A literal example from a problem I had in the blog. So, this is your code. You need to open something in your path. But since you are doing a unit test, you don't want to touch the disk because it's considered bad practice. So, what should you do? This is the solution that was proposed to me. Monkey patch. You can just monkey patch the open method. This is the mock for the open, and you check that the open method was called with what you expect. So the open method returns a file, an open file object that you want, and then you check that that file is written with the proper thing you expect. This has a big problem, a huge problem. You are coupling your test to the implementation of your code. Suppose you refactor. You don't use open anymore, but use twisted Python file path, which is a wrapper library. This is exactly the same way of working. This does exactly the same thing. So, can you guess what happens with the unit test we wrote in the previous slide? It doesn't work, because monkey patching has tied your unit test with your implementation. So, how much do you value a unit test which breaks when you refactor your code by keeping the same functionality? This is not a good unit test. You should not do something like that. You should do something like that only when there is a third-party library which is not under your control and you can do nothing beyond monkey patching. It's an extreme issue. Consider the same example and use dependency injection. Here, you don't care about this object does. The resource has a totally different concept from your own class. You just code the interface as you would like it to be, and then you use it and you inject it in your code. So I had one point in this, and it's told me, yes, but if I take all the files and I inject them around, I have 1,000 open files in my application. I say, that's a different concern. You should not think about that in your class, which has been injected, because you would break the single responsibility principle. So, a good idea would be to just, okay, sorry, this is the test with injection. You need to do nothing, just inject in the constructor your own file. And if you really needed something like an object is a got-enough file which is not open unless it is accessed, what I did in Dependency, for example, is to create a lazy resource object. I mean, you don't have to use built-ins. Some people who program in Python just thinks, oh, it's a built-in. It's a kind of high-level object. I just want to use it as it is. I don't want to wrap it. I don't want to do anything with it. It's something like there in some word. No, you should always think that in the interface you really want. This is my implementation just did something like performing an existence check or accessibility check or instantiation, and then when somebody weirdly tries to read the file, then the file really gets opened on this level. So, Dependency is a tool which was used for internal projects so far, and it seemed working. Now I'm trying to make it public. You can take a look at its code, you can try to use it, and I would like to get feedback and user stories, because I'm doing very little development with Python on the web. And I suppose that many people would like something like a dependency injection for Django or for other web frameworks. I think that would be a fine idea, but I don't have a real use case for that. Here, you've got some references, and you can find them on the repository later on. And I'm done.
Is it reasonably easy to go back to the encapsulation slide?
Yeah.
The first one where you have the definition of encapsulation.
Yes,
this one. The first thing that came to mind as I read this, this is the right definition as long as you change one syllable. Before, they only read, changed accessible to accessed.
Yeah. Yeah.
The problem is not whether it is possible to do stupid things, is whether that is accessing bypassing interfaces. The problem is only whether it's actually done. And remember, you can never make anything foolproof because fools are too smart.
I'm going to follow up on Alex's comment. I wrote that and put my focus on the interface is supported by the object. Well, if we say anything we're going under at the beginning is not an interface supported by the object, then perhaps aren't we okay?
I don't understand the question, sorry.
The ISO encapsulation says that the information contained is accessible only through the interface supported by the object.
Yes?
Well, we can simply say using an under method, using a private by convention method, is not a supported interface.
Right, but it's not forbidden.
Right.
It is possible to.
It's possible to use it, but this says only. You may understand. And the problem is that when you're programming, you can never say that this only is true. It's accessible, like Alex said, would be a better term. But this is not my definition. This is just a copy and paste, okay? ISO. I think that encapsulation and abstraction are two concepts which are used in 1,000 different ways, and there is a lot of difference between them. Something that is an encapsulation or an abstraction for something else, and abstraction and encapsulation is a process as well. So you do abstraction when you design an object, but an object may be an abstraction for something else. So there's a lot of lingering in those terms, and there seems to be no clear literature on what to say. Yes, this is a good definition. So I just had to guess.
Yes, I think that's not true in any language, by the way, because the only difference is that Python makes it easier. It's always possible to, you just look at the memory if you want.
Yeah.
My question is, the quick one about the first slide, I think, one with user calls to class. It was the very beginning deck that you used as an example of
the constructor injection.
Backward, there was an app,
This one?
driver, and isn't the association of user repository and use of dependency injections in itself because it takes just one driver? Wouldn't it be possible?
Yes, but the problem is that this is probably a business object, and you don't want to tie this dependency your business logic. You might want to use a different repository. There was a later slide. Sorry. I can actually find it. This one. You may want to switch implementation of a user repository in different contexts, in different applications, at different times in the life of your application. So, if you're instantiating a concrete user repository, you lose the ability to do this.
Yes,
And you're using a concrete DB driver as well, while you may want to switch databases at another time.
And another thing, how do you feel about taking this concept and thanks to the dynamic nature of Python, pushing it to the limits, like why not a superclass injection or something like that? You can do almost whatever you want.
Superclass injection. What do you mean by that?
And building as your at one time, not time limits.
Although I think it might be possible, but I don't know why I should do it. I cannot find a good use case. I think that explicit is always better than implicit. So I think that building a class security at one time might be a hard thing to do. And if I can understand what is your concern, you may look at traits. I think that Anthropo has got a traits library. So if you want to take small pieces of code and compose them together without using multi-level inheritance or without using multi-inheritance itself, you can use traits, which is just another way to achieve the same thing, so to achieve code reuse. You can take it whatever you like. Dependency injection is a principle. You can break it sometimes if you want to, and if you know what you are doing. But I think that in many cases, if you don't think about it, you risk breaking it when you don't want to do it, and then it's too late, and your code is already too tightly coupled to be separated later on.
Did you also evaluate the concept of utility from the SOAP component architecture for using dependency injection?
Sorry, could you repeat?
Did you also evaluate the utility concept from the SOAP component architecture for dependency injection?
I think I don't know what you're talking about. Sorry.
The SOAP component architecture has a similar thing where you can inject or load modules independent of the implementation.
Sorry, now I understand. I thought it was so. Okay, I took a look at Zope component and Zope component and Zope interface. I don't really like the way it works, but it can be used to achieve the very same result. Yes.
Yeah, I'd like to ask a question about configuration. If we could go back to the slides where you have the import statement.
This one.
Back.
Back. No.
Back. Back. Right at the beginning.
That's the problem with sticking to one interface.
So at the top there, you've got a configuration. It's in the wrong place. There's a configuration of the system. We're importing stuff from somewhere else. We've written it. Use a repository of MyDB driver.
Right.
If you,
Okay, this is an oversimplification.
yeah. It's a simplification.
Yeah, sure.
Yeah. And when you go forward one,
Yeah.
you've lost those import statements, and I think that's really important. But
Because you don't need it?
yeah, because you don't need it. But those import statements have to appear somewhere else.
Sure.
And
But they appear later on, when you really know what the implementation that you want to use in this case, and you don't have a transitive import, for example. So, why does the user service know something about the DB driver? If this is a business object, he should not know anything about the DB driver. So here, you are tying very different layers of your application.
I'm not saying that's right.
Okay.
Okay, I'm saying that the import statements are necessary and they've been put there. Now you've removed the import statements
Yes.
in the next example, but they have to come somewhere. And
Yes.
what seems to be a bit missing from the whole mix is a way of saying, this is my configuration object, use it to construct the system. At the top level, we want to be able to say, here's my system, here's my configuration,
Yeah.
build the system according to the configuration.
This is what is achieved by using the configuration object later on and the application context. So this is a way of achieving a dynamic import to strings to prevent a lot of import compared to the beginning of the code. So this is like a twisted Python name a DAG function. I don't know if you have heard about it. It just takes a string and imports the object with such a fully qualified domain name. So this is a way of configuring a feature in your application. You just take the class and set whatever dependency you have. By marking something like with provider, you say that this class should be configured in a certain way. For example, the default is synchronous scope, so once you invoke such function once, the result will be cached and will be returned every time anybody calls this function. Lazy init means don't instantiate this object as soon as the context goes up, but instantiate it only when somebody requests this object for the first time. I didn't want to go deep into this concept because they are very similar to the ones used in the Spring Java framework. But if you have got a specific question or anything that you don't like,
I find it a bit hard to understand that stuff.
okay. This is a configuration. What does it mean? It's a kind of pre-baked mix of objects. You may use it, you may not like it, you don't use it. So if you take this, you've got some public methods that make for public providers for the object. So it's what you want to configure. This is a kind of Python code version of the large XML block you saw at the beginning. It achieves the very same result. The first time the user calls provide user service, you see the name here is the very same name of the method here. So this configuration says, this configuration provides to the external world a user service, an object called user service. It contains just configuration. There is no application logic here, as you can see. It just says, call this other method, which is a provider as well, a private one, because you don't need to expose this detail to the outside world. This one calls for a DB driver, which was registered, which must be registered in the global context, since it's probably a cross-cutting construct. Okay, this is just a standard. All right. Now, stop me if I'm not clear enough.
Well, it seems to me it appears as though you push down the complexity here and it's popped up there.
So this is an example, as I
I'm
said.
not saying it's bad to push it down here. It might be good to push it down here and have it pop up here, because here might be the right place to do it. It seems as though there's a complexity about configuration that has to be dealt with.
Okay, I think that configuration is one of the hardest things to get right. You can find a lot of things, a lot of software, which is good, written in a good way, and then it's configured in a bad way, and you can't change anything. So, as long as you don't need a container, as I said before, don't use it. I didn't use it as long as I didn't need it. And then, when I found that my configuration was so large and so complex that I could not cope with it, It was impossible to handle. And every change in the configuration of my application, which was just plain Python code, was really impossible. Then I wrote this. What happens here, even if you may not recognize it from these small examples, because the talk was not on my lazy, I didn't want to do it, is that this is a kind of declarative. So you don't mind the order in which dependencies are created. You just call a method, and then the dependency resolution chain will do the work. Otherwise, you need to always take into account the way the object must exist in the first place. So you first need to create a DB driver. Then you must create a user repository. Then you must create a user service. If you do this in Python, you've got a very precise order. Here, you can just write multiple methods and invoke them as soon as you need it. You don't need to think on when to invoke them, what you need to invoke before the other. So that's part of the complexity that is taken away with an IOC container.
How do you use the user config object?
What?
How do you use it?
Here, create an application context. You register, okay, this is a driver. Then you register the configuration. You start it, and then you just ask for an object by name. This is the very same name as the name of the public method here. And as soon as you call this method, you will be provided with an instance of user service. And this instance is a singleton because you call the container to use the singleton scope.
I was just curious with PyDenji, what specific issues with other Python dependency injection libraries are you trying to solve?
Okay. I have tried a few of them. I have tried Snake Twist, or Joyce, I don't remember how it's called. And I tried Spring Python. I couldn't feel they were working right. I mean, Snake Twist has a problem, in my opinion. It requires you to use decorators to tell the application what the dependencies are. So you just write, instead of doing something like that, is you take your business code, this is not a good example. You take your business code, you put a decorator in there, and you say, here I want a user repository. I don't like that approach because it makes your code dirty. You need in order to use an IOC, then you need to depend on an IOC. You don't have to do this with PyDenji. You can write your business object, you write them, then you try using your normal Python configuration, just plain code, and if and when you need an IOC, you use an IOC, and you probably won't see any import from PyDenji unless it is your main configuration class for the service and your main application context. You do not pollute your code with things that are not part of the interface. In Java, there is a JSR, like a path for annotations that you can use, so you don't depend on the implementation of an IOC, but you depend on the interface for injection. In Python, you can't do that. There is no API for this. And about Spring Python, I have tried using it many times. I did not want to code my own solution, but I found it very hard to use because it seems to be a Java tool. A lot of Java programmers who are trying to convert the whole of the Spring framework to Python. I tried to contribute patches, I tried to do things, but it was too strictly tied to this idea. And I wanted a smaller tool which just did dependency injection and inversion of control. Nothing else, no GMS, no strange things that have nothing to do with the Python world.
Which advantage does it have above using entry points from setup UI?
Entry point? API to achieve dependency injection?
Yes, because you could have different eggs with different implementations.
Sure, you can use different endpoints to configure different application contexts, or configure different classes that configure. But that can be done. But what I'm saying is don't take for granted that you need Pydancy. The test is something that I have used with success. If you don't feel the need for it, then, lucky you, don't use it, and I hope you never open a bug. Any other question?
So let's then kind of